Good evening, everyone. Welcome back. We will continue with our Docker session. So today is Docker day 6 session, and the date is 15th of your March 2025, and the timing is evening 8:04 p.m. IST. So guys, today, as we know, like this is Docker, and we are doing it only on weekends. Right, probably after some time we will try to shift it to the weekdays, right? Once we try to cover some other DevOps tools which we are doing, right? Like once that completes, I'm plan to shift into the weekdays. So only based on your discussion, based on everyone's approval, I mean, if everyone agrees, then only I will push into the weekdays. But till that time, we will try to do only on weekends only. Okay. And we will see today, if possible, I'll try to take 2 sessions, or else we will try to complete in 1 session only. Okay. I might take a lengthy session today, maybe around 2 hours. Like if that is the case, then I will not take another session. We'll try to close with 1 session only today. Okay. So today is a day 6 session, guys. So before we get into the day 6 session, let us try to see what we had covered in the day 5 session. So in the day 5 session, I remember like we had covered about something about the lib container, right? So we try to understand what is a lib container. So lib container was one of the very important component which was designed later by the Docker community, because the Docker client, whenever it want to execute anything, it was tightly bounded with the Linux kernel. So if there is any kind of a changes happens to the Linux kernel, right? So what are the containers which are running in the system, right? That should be stopped actually, or it will go automatically get stopped, because if you're upgrading the Linux kernel, it will get stopped. So to resolve this problem, what the Docker community did, right? They try to create a lib container. So now your Docker client, what are the Docker client is there, right? So if you see the diagram, this is the Docker client. Now this Docker client will no longer depend upon the kernel now. It depends upon the lib container actually. So about lib container. So with the help of this lib container, so what happened, right? Basically, it will try to, like whenever a Docker clients want to execute any task, or it want to run any container, it try to connect to the lib container. And lib container is the one which actually does everything. It means that it is the one which is going to create a container. But it's not only the lib container, there are many other components come to the picture, which we will discuss in today's session. But in a very high level, I'm saying that whenever the Docker client, it want to create any container, when it try to send a request or event site, when it tries to run any command related to the Docker command to create a container, then the request will go to your Docker, what happened to your Docker engine or to the Docker daemon. In the Docker daemon, there is something like a lib container will be there. So here there will be lib container. So that lib container will take care of handling the request from the Docker client, right? So we had discussed about that, right? And then like we try to install the we try to install the Docker onto the Ubuntu Linux. And also I requested that you need to have all these softwares, what is required, right? So pretty much we had covered in our last session. So I remember we had even covered 2 sessions on that day, right? Day 4 and day 5 session, we had covered it actually. So I'm not going to discuss about what we did on day 4, right? And also at the end, like we try to run the first container, right? We also saw how to run our first container. So this is what pretty much we had covered in today's session. So what we're going to do today, guys, today we are going to understand about the little bit in detail about the Docker architecture, and also we will try to see like how container works, right? And we'll also see about, we'll just try to have an introduction to the Docker commands, not into very in detail, because we'll have a dedicated sessions upcoming. Maybe tomorrow or the next weekend we'll have a Docker session, because tomorrow also I would be discussing more about like about the container, about the distro or distro less everything. And also if possible, I'll also start with the Docker command also tomorrow. So when you start Docker command, it will be pretty much very interesting, because like something like 2 to 3 hours we'll be spending only on Docker commands. Not 2 to 3 hours, more than that, like 4 5 hours we'll be spending on Docker commands. And Docker command is also very important for all of us to understand how Docker works actually, because we have so many options, so many like modules are there in the Docker. So we have to cover many things, right? So that's the reason it itself will take around 2 to 3 sessions on Docker commands. Now, so one important thing which I told in the last session, that like whenever we are working on Docker, we should have a hub.docker.com. I mean hub.docker.com. This is nothing but uh, your registry actually, which you call the public registry. Always you need to have an account under the hub.docker.com. Right? So with this, what happened, right? If you have this account, then what happened, right? You can go and suppose in case you don't want to install Linux and you don't want to have a Linux and you don't want to even install Docker. Assume that you want to just you want to practice the commands itself. There's always that you have to go with the Docker playground actually, like this. If you go with the Docker playground, and then like if you try to go to this site lab.playwithdocker.com, right? So how you will be able to open it? If you have this Docker hub.docker.com account, then only it will work. Otherwise, it will not work, right? So it will ask you for the login. So if you click on the login, it will ask you for the which is the user. It's a Docker, and if you connect it to it, and if you say start it, you will see that you will be able to get a session where like you'll be able to do it. So you could see that once you start the once you start with the Docker playground, you'll get as a session for 4 hours actually, and you can do a lot of activity. Like if you click on the add new instance, say, can you see here, guys? You got an instance actually where you have this Linux machine, and like basically you will be able to execute any command. So whenever you want to do the full screen, you have to press alt and enter, and whenever you want to decrease, again you have to say alt enter, right? Alt and enter, like this, right? Alt and enter. Now if you remember, like the first container which we had executed was hello world, right? So how do you do that? We execute a command docker container run, and you just say hello hyphen world. Right. So this is what we have did it. Docker container run hello world. Hello world is an image name. Now what happened, right? As per the diagram, right? What happened? The Docker client is executing this command. This is a command it is executing. So what the Docker client is doing, this is a Docker commander, or we can call it a Docker client. So the Docker client basically what it is sending a request to a Docker engine. So your Docker engine is running in your operating system actually, because you have installed Docker, right? It is a part of your operating system. So this Docker engine or the Docker daemon, or you can call it a Docker server also, anything, you can use any nominal naming convention, Docker engine or Docker daemon or Docker server. Usually in the organization, we use the term always Docker daemon actually. So this Docker daemon will take a request from the Docker client, right? And the Docker client also takes a request, and in turn what happened is Docker daemon is going to create a container. But who does actually, it doesn't, it, who does actually the work? Everything is done by the libcontainerd actually. So libcontainerd is it's a library which is written by the Docker community itself, that will take care of creating all your container, everything, managing the container, creating the container, right? Everything. But how exactly it does, basically what happened, right? Your libd container, it is going to check in your local machine itself in the image store whether that hello world image is there or not. If it is not there, then what happened? That will try to fetch that image from the Docker registry. So Docker registry is nothing but it's a public repo, public registry we say, which is nothing but hub.docker.com. So whatever we saw here, right? This is nothing but the hub.docker.com. From here, it will try to fetch that image and it will store that image locally in the system. So from there, what happened, right? What happened, right? It will pick that image and it will try to run as a container. So one question might come, you might ask, Rajesh, is image is a container? Is image what we have is a container? That is a one question which will come to your mind. Okay. And the first is that what is image actually? What is an image? That's the first question. And the second question is image is a container, or whenever we are creating a Docker container, whenever we are running, or whenever we are, you can say running, or you can say creating Docker container, does it needs image? So these are certain questions which will come to your mind, and we will discuss all these questions today. Okay, some of them, not completely, some part I will explain. In tomorrow's session, we will see that I will be elaborately explaining about. So today I might say something about the image, but tomorrow you will see that I will be elaborately explaining about the image itself actually, because we'll go in deep dive into image and try to understand more about the image. All right. So every day what happens, something new will be learning in conceptually in all this, like whatever we come across with the Docker, right? Many things will be keep repeating many things, and something or the new I'll be keep on adding in every session, right? So now these are certain things which will come to your mind. Okay, fine. So right now, what I would say that actually, like whenever you want to create a container, we need an image actually. We need an image. Without an image, we cannot run a container or we cannot create a container. Image has to be there, right? Now the question comes that what is an image actually, right? So in a simple term, I can say that image is an package, is a package which which consists of base OS plus dependencies plus bin libraries, binaries or libraries we say, plus your application. So image is a layer of all these components. So what are those components? Those components are base image, base OS. Oh my God, what is it? Base OS dependencies like this. It's a layer actually. It's a layer of all these components actually. So at this point of time, this is what I can define what is an image. Later we will see what exactly is image is all about, right? We will see how images are built, right? Why we need an image actually. Without an image, can we run it? And what is this base OS? Whether without a base OS it works, or what is it? So many things we have to learn, understand about the image itself. So we'll slowly try to learn all these things. Okay. So now, so coming back here, now when I said that when you were trying to run a Docker container run command, so basically it has to fetch for it has to check for that image. If that image is not there, then what happened? Your Docker daemon or nothing but the lib container, it will try to fetch from the hub.docker.com. Right. So you have now the question comes, Rajesh, how your Docker can able to connect to it actually. There is a connection establishment will always happen whenever you have installed Docker actually, right? By default, what happened, right? There will be a login would have already happened with your hub.docker.com. So that's the reason it's going to fetch it. Okay, how everything happens, we will see later. But right now, understand that your Docker daemon or the Docker engine, it can able to connect to your hub.docker.com. From there, it will try to pull the image. Okay, so once it pulls an image, it stores in an image store, which is locally maintained by the Docker daemon itself. Locally, it means that Rajesh, the Docker daemon itself has a local database. A local store database will be there. That database maintain only the images, in only the information about the images. And once that image is there, so what will do that? What the Docker daemon will do? The Docker daemon is going to take that image and it's going to run it and it's going to create a container out of it. So this container it will be running actually, right? So whatever the image is there, right? That image will be something like an application, and that application will be running inside this container. So now you could see there is something like a box you are seeing it. Inside this box, some application is running. And how that application is running? With the help of an image actually. And what is that image? You can say that, sir, image is nothing but it is a combination of base OS, dependencies, libraries, and application. Okay. But what exactly is image? You can say, Rajesh, image is something like it's a disk file system. It's a disk or it is a storage or it's a file system which has an information about the application. Right? So that is all about the image. Image means image has a application actually. It has an application. And that application, so that application is stored into some disk file, and that disk file is nothing but the image actually, and that image will be loaded inside this boundary which we call the container, and that application will get executed, or the application will be running actually. Who is going to maintain the state of the life cycle of the Docker, everything? Your Docker daemon will maintain the life cycle of the entire Docker container. Am I clear, sir? Sanjay, Sarvanan, did you understood? Do I have to report it again? Do you need any repetition?
Yes, sir. Due to networks, just now I joined due to some network issue.
Okay, that's fine. But whatever we discussed so far, did you understood?
Yeah.
Okay, good. So it means that whenever a container has to get executed, or whenever the Docker container has to be get created, it needs an image. An image is basically, it is a combination of all these things: base OS, dependency, libraries, and application. Strictly speaking, it's an application actually, right? And what is that application is all about? Application is a thing like, say for example, you have some website, that is an application. right? A website, say that's an application, or else you have some Python code, that's an application. And to run a Python code, right, it needs some dependency. Say for example, I'm just taking an example of Python. You have a Python application app, which is an app, but this Python application, it needs a dependency. Say for example, it needs a dependency of Boto3 library. Boto3 library. So this application, whatever you want to run, that is the Python application, and this dependency is something like it's a Boto3 library. Okay, and then you need some kind of a base OS also, right? A small OS, base OS is required, where you can go and you can place all these libraries and the app. That's what you need, a base OS. So, and there are some other binaries are required, some other executables are also required for you to run that application. So all these combinations is nothing but your image actually. Right, similarly, for example, how I can say, sir, for example, some you have some like a .NET application is there, right? For the .NET application, the dependency is something like it needs a .NET framework actually, .NET framework or .NET framework core. That is a dependency. So when you have an image, that application is that, but some .NET app actually, and then like for it means that whenever you want to run or execute the .NET app, it needs a .NET framework core, and that .NET framework core is nothing but dependency. And of course, there are some other binaries are there which are required, and base which is there. All this together is called it as an image, right? And this image is what, as a part of container, it will be executing inside this container. So this is something like a boundary. Okay. So what is a boundary? Okay, you're saying something in the box it is showing, but in actually, what is a boundary? A boundary is something like, I can say it is like an isolation area. It's a small piece of area, memory area. We can call it a boundary, right? So within that boundary or inside that boundary only, the container will be running, right? And this boundary is not, but it's an isolation area. And this isolation area gets some kind of a it gets some kind of a features it get actually. So what are those which we call it as a namespace actually, right? Whenever the content is getting created, how exactly the contents are getting created? The contents are getting created with the help of something known as a namespaces, and we call it as C groups actually. So the combination of the C groups and the namespace is something nothing but the who is a creator of the container. You have to say, you have to ask the question, who's the creator of the container? Sir, it's a C groups and it's a namespace. With the help of the C groups and namespace only, the Docker containers are getting created. This boundary, whatever the box I'm saying, right? Okay. What is that namespace? What is the C group? Yes, we are going to discuss in today's session. A part of it we are going to discuss, not completely. In next to next session or in upcoming session, we'll be elaborately learning many things about the namespace and C groups and all. To little bit extent, we are going to understand it. Clear? So now, good. Now, when I try to go over here and I try to run this one, we know that right now we are running for the first time Docker container run hello world and say enter. You could see that it is unable to find this image locally. Now it has pulled it from the library, which is nothing but your hub.docker.com, and then the pull is completed and it is even executed also. So whenever you see some big number like this, or SHA 761844, some big number, if you see like this, what you need to quickly understand that, okay, the Docker container has executed successfully. That's the reason you're getting this big number actually. So if you ask me, Rajesh, what is this big number is all about? 76 with the help of a SHA 256 algorithm, it has given this number. But what is this number is all about? So this number is all about something like it's a Docker ID or Docker container ID, we say. Right? So whenever Docker gets created, right? Whenever a Docker is getting created, always a Docker daemon is going to assign a Docker ID or a Docker name, we say, right? So Docker name or the Docker ID, these are the two parameters will be assigned to this name. It means that whenever a human want to understand or we have to understand about what is this content all about, what is the name, so we need to either we need to give a name or else the Docker engine or the Docker give a daemon will give a name for it. And simultaneously, what happened? It also provides something as a Docker ID, and that Docker ID information is internally used by your Docker daemon. So whenever Docker daemon want to do any operation onto the Docker container, the Docker container will have something like a unique number. We call it as a container ID, and that container ID is given by your daemon itself. Now, whatever you are seeing here, see, whatever you're seeing here, it is nothing but your Docker container ID. Okay. So now it means that it has executed. As part of this execution, what it has happened means, guys, it has actually pulled the image as I said, right? And then like the pull has completed, and finally it has showed that actually that it has executed that container. As part of the execution of the hello world, that is nothing but colon latest. What is this latest? It is nothing but tag actually. We will discuss about this later, right? Image will not be with the image, just with the name. It will be associated with some tag actually, and it is showing there's a colon latest. Oh, it means that Rajesh, every images will have something like colon and the tag name. So here it is showing the latest. Okay, it is something like it is the latest image which is available. So it has tried to pull this latest image, and then like it has executed it, and that's the reason after post execution or post creation of the Docker container, whatever this hello world is the right, that has printed this string actually. It means that if you dissect this, if you dissect it, it means that if you open this content, if you open this image and try to see inside what this image has, it has this message actually. Am I clear on this, sir? So don't worry, guys. We are going to understand about all these things. Okay, we are going to deep dive in all our upcoming sessions. We'll learn more and more as and when our class, our session get progress. Right, you will see that you will be learning many things actually. Right, so that all your some of the questions or doubts, whatever you have read, that will get clarified over the period of time. In another 3-4 sessions, everything will get cleared for you. Okay. Now, so it has pulled it. Now suppose assume that I try to run the same command again one more time, docker container run. This time you see that it will not try to download it. It will not try to pull that from the hub.docker.com because this image is already there. So where it is there? It is there in your local store or nothing but image store or nothing but the database. Internally, it is already there. So what it will do that? Let me clear the screen. And again, I try to run the same command. Now you could see that it is not pulling, it is directly executing it. And you could see that actually it is showing the output. Right now, right now, if you want to check like what are the images which is there in your system, right? What are the existing image? So I'll just say docker image and say ls and say enter. Can you see here, guys? It is having this hello world, the image, and then it's the latest, and you could see that whichever it got right, it has 7 weeks ago it was there, and the size is just 10 kilobyte actually, right? So now we know that like this is what the command we use, docker image ls, right? And like this is what the image is already there. Now, whenever, so this is one thing, fine. So there is one more image we always use frequently, which we call an alpine image, right? If you go over here into your hub.docker.com, and if you go to the explore, and or else you can go here and try to search for alpine, alpine, and say enter. Or I'll just say Alpine. Or if you say just Alpine also, we can able to download. So Alpine is a very base image actually. That's a very base image of your kind of a Linux operating system. If you want a Linux operating system, a very base small image. See, suppose assume that actually you go and you try to download the Ubuntu image from the ubuntu.org. You try to download it. It will show you whether you need a server image, you need a desktop image, or you need some other image. Okay, it'll ask you for some options and all. You need to provide which kind of a image you need. And if you try to download that image from the internet, from the Ubuntu or org, if you download, no, that image will be something like some 700 or 800 MB image, a big image will be there. So that could be a desktop image. So 700 MB of OS size or the image is, you see, Ubuntu OS image, it would be around, I'm just saying something like 800 MB. 800 MB is very big size, man, because this image is number, it supports for a desktop OS actually. Your desktop Ubuntu OS it supports actually. Suppose you want all kind of a desktop operation, right, where you have to do everything through the GUI, then obviously the image will be very big actually. And you try to download this 800 MB and then try to flash it into your USB, and you when you connect to your USB and then try to boot up your system, it will detect that the that your USB has some OS actually, and from there you can go and install the Ubuntu operating system in your machine. You can do that. Now that image is an 800 MB image, and that image has to be copied to your laptop when you're trying to install it actually. So that everything your like installation process will do that actually. Now you say that Rajesh, if I'm having so much big image, do then do you think that I'm going to run such big image in the container? Yes, of course you can run it. 800 MB you can run inside this container. No doubt in that it will support. It depends upon your system's hardware. What is the hardware? How much hardware is that? It depends upon that. But running such a big application or big OS everything in container is not good actually. Not that is not a good practice. So whenever you have a container or whenever you containerize any application, always we say that the containerized application will always, the size of the containerized application will be very small. It will be in some few kilobytes or just it will be hardly some 1 MB or 2 MB. It will not be something like 800 900 MB. It will not be that much. So we never ever try to have an image which is 800 MB and we try to run into the Docker container. We don't do that, right? That is not feasible also, and that is not a good practice. So always we try to make sure that whatever the image which we are building, that image should be in very few kilobytes, or max to max it can be 1 MB or 2 MB, not more than that. And here I'm saying it's an 800 MB. So Rajesh, do you have any alternative for this 800 MB where I will get an operating system image itself, kind of a Linux image itself, but it should be very small? Yes, sir. For that we have something as a Alpine image. Alpine image is a small image of Linux based operating system. Right. We have something known as a distro-less image. We will be discussing about that also in tomorrow's session. Okay, in or the next session. What is distro images and all, like where we use it actually. All such things are, we will be discussing about this also. Right. So now you say that Rajesh, I want to run this Alpine image actually. So what you can do, you can go back to your container, sorry, playground, and then run a command, Docker. Don't worry about the command, guys, as of now. Okay, don't worry about the command. Anyhow, we will be learning everything. I'm just trying to observe what I'm doing it. So Docker container run. Okay, hyphen D. Don't worry about this. Hyphen D is detached. I'll just say Alpine and say enter. So you could see that actually it is unable to find it locally. Hence, it is trying to pull the image, right? And then like you could see that actually it has downloaded and it has extruded also. Now, if you try to run a Docker image ls, can you see here, guys? You have downloaded the Alpine image, okay, and it is just 7.83 MB. It's a very small image actually. It means that at least you are compressed. You have an image which is of 7.8 MB. Of course, you will get even less than this also. We can even build an image, or we will have a lot of images which is less than even 1 MB also. But Alpine is something, okay, we use it heavily in most of the when you are trying to build an application where it needs an operating system also along with the application. So at that time, we will go and we will try to choose the Alpine image actually, or else we'll try to use something like a distro-less image also. We'll do it actually, so that we can have a container size which is very small actually, right? I mean that image size very small, right? So this is something like, okay, we saw that, okay, Alpine is same thing like a Linux based operating system image, right? Now the same thing again, when you try to run the same command again, enter, you could see that it will not try to download it actually, it will try to execute it. Can you see it has executed it actually, right? As part of execution of this, it has nothing that has did actually, because there is no instruction to say that what should be done as part of executing this. This is just an OS image. So when you try to run it, it doesn't do anything. It'll just try to create a container and then exit it out automatically, right? Is it fine, guys? Right. So in the last session, we had discussed about all these things, that it fetch the images if it is not there locally, and then like it'll try to run it. Let me try to write a small note on it. Okay. Because in the last session, if you see it, I've just said running our first container, but I didn't write it actually. Okay. So running our first container. Okay. Let me try to copy this, have it here. So to run the Docker container, we need a Docker image. Docker image, as I discussed that, which has all the necessary stuff packed. What is it? PSCKAD, right? Packed to run the application. So what are the steps it does actually? So the first step is that actually Docker container run, 1 second, Docker container run is, you can say Docker container run is issued from client, and then like Docker daemon, actually Daemon, checks in the local image store, right? If not present, it downloads from registry. So the registry here is nothing but your Docker Hub, here or hub.docker.com, whatever, right? And finally, what has happened, right? If okay, if it is present, then what it will do that it will try to run the container. Am I clear on this, sir? Okay. So now this is good. Now, whenever there is no image, right? For example, Rajesh, I'm running a container like this. Okay, but there's no image. For example, Alpine, something XYZ, something I'm giving some nonsense image name. If it doesn't, I first will try to find out whether this image is there in your local or not. If it is not there, I'll try to fetch from the registry. It's nothing but hub.docker.com. There also there's no image with this name, and it will try to throw an error. See, it'll try to do it. So what it's an error response from doing pull access denied for playback, right? A repository doesn't exist or may require Docker login denied. Request access resource is denied. It means that there is no image with that name at all. Hence, your Docker run container run has failed actually, right? So to view the images in the Docker local store, we execute the command docker image ls. Now, guys, now we have to understand few of the commands on the Docker. Few of the commands. We'll start with a few of the commands. But what happened, right? Like when the Docker was started, like say for example, 10 years back, when the Docker was started, right? Docker was basically started in, I think in 2012, it was started, the organization started. Almost like it's been 13 years. So during the start of the Docker, when the Docker came into the world and when people started using, right? They were using some set of commands, Docker commands, right? And now, latest what happened, right? In the latest from last 5 years, Docker has did a lot of changes into the Docker commands actually. Even in the command line also, a lot of changes has been done actually. So we need to have an understanding of both the versions. What was the previous version or the very at the early beginning, what Docker commands were used, and today what we are using it. Like we'll be seeing both the things and we'll try to understand it because they have did some kind of an improvisation actually, right? They have said some kind of improvisation. How they did it means in the latest from last 3 4 years what happened, right? They have added something known as a module actually. So they have added, okay, the Docker community has added a modules actually, added models. Hence they have changed few things in the Docker command line. It means that when you're running, when you're executing the Docker command now, right, a lot of changes have they have did it, and people who are working on the Docker, right, they know about what are the latest changes it has there actually, and how to make use of it. And everything they have learned it, people are learning it, or they know it already, and people have started slowly. No, they stopped using the older one actually. But still, what are the latest we have for the backward compatibility? Still, they are supporting even the older execution of the commands also, right? But what happened, right? Because since most of the people, many of the people in the organization, they've been using Docker from long time, they are aware of even the latest command line as well as the old one also. So they are aware of it actually. Say for example, earlier what happened, right? I'm just giving an example. Say for example, in this case, suppose I want to display all the images, whatever it is there, right? The images which is there in your local store. Then what I do, I use a Docker images, right? Docker images. So this is the older command. If I execute Docker images and enter, can you see here, guys? It will show all the images which is there in your local store, right? This is the older fashion or older way of displaying the Docker images. Now the new one is what? Docker image and say ls. See, this also gives the same output. Now this is the latest way actually. You have to say Docker image space ls. So you might ask, Rajesh, then how Docker images is still supported? Yeah, for some backward compatibility, still they are supporting it. Later, after some point of time, you'll see that they will remove all this older version concept. They will remove everything. Only the latest what is there, right? Only that would be supported, right? But still, being a person who knows Docker, right, you should be a little bit aware of even the older commands also, because sometime what happen, we might tend to use older commands also when we are working on to the system, right? We might use it. That's the reason you should be aware of it actually, right? So same thing what happened, right? For example, I want to give one more example. Say for example, if you want to display all the what I can say, uh, all the content which has been executed so far. So what you will do basically, let me clear the screen. I'll just say docker ps-a. So this is the older version of the command, of the Docker command. If you enter it, it will show you all the contents which has executed recently. You could see that I have executed hello world twice, and also I have executed alpine also. This is what the older version. Now, what is the latest version of the command which you are executing now? So for the latest version, I always say docker container ls-a and say enter. See, this is the newest version actually. Now you might ask, Rajesh, if you have, I have to do use this one or this command. Sir, please always use this command only. The latest one, which is number docker container ls-a. This is what the command which is used to display all the contents which has been recently executed. Even though both are showing the same output, right? But this will be obsolete in some time. I mean, this command, they will try to remove this option and command also. Am I clear, sir?
Yes, sir.
Okay, good. Now,
Sir, what is the difference between these two commands?
that's why there's no difference. Output is no difference. This is the older method, older way of doing, and this is a newer way. That's what I'm saying. You have
Okay.
to learn the newer way, not the older way. That's what, if you go back, I executed Docker images, which is the older way actually. This is the older way. But latest what we have, Docker image ls. This is what we all have to learn actually. So what I'll be doing in our classes, I will not execute any older commands, so that you only use the only new commands only. Right? But some people, as I said, right, old people who have been using Docker from long time, they are aware of both old and new also, because it is supported. So suppose in an industry, if you go here and if you try to see some old command has been used by your colleague or somebody, Docker ps hyphen, you don't get confused actually. You might say that, okay, Rajesh never taught us. It's not like they're not taught us. This is there already. But what happens, slowly it will get obsolete over the period of time. Right? They will remove it just to have a backward compatibility they have kept. So that's all. Otherwise, they would have removed long back only. So this changes and all been done by like 4 years back only. 4 years, since from 4 5 years only, all the latest command has come have come actually. It means they have changed all the to the latest command. I don't know why Docker community still they have kept this older command. I don't know, for some compatibility issue they have kept it. Otherwise, it is not required. They can remove this option and all, so that from next time it will not work. Hopefully, in upcoming days we will see that it might be removed actually. Right now, there's one more important thing, guys. See, whenever we are learning any Docker commands or something, we are executing Docker commands, right? We need not to really mug up, or we need not to really always remember. As I said, right, we need to use so much that it should be a part of your existing knowledge. So whenever we learn anything, right, when it becomes a part of existing knowledge, then we will be easily using it. All those options are the commands on our day-to-day activity. So you have to practice though such so much that you should know all the commands automatically. So remembering the command or mugging up the command is not a feasible way. We shouldn't do like whenever we are learning anything. Now, always what happened, right? Whenever you try to learn anything, actually you can learn any commands in a command line only. Say for example, okay, I'll just say getting started with Docker commands. So guys, as I said, right, we have a dedicated 2 sessions only on commands. I'll be explaining more and more, but just we are starting it now actually, right? So there are 2 ways are there. What are the 2 ways actually? So 2 ways is something like where you need to use always help menus actually. Help menu. What is this helps actually? We'll see now. The second method is always that you can even depend upon the cheat code also. The problem with the cheat sheet actually, one which I want to tell you that most of the cheat sheets and all, they have shown everything Docker commands in an older method. It means that whatever the older options were there, right? That is what they're having. You'll find very less cheat sheet where they're shown everything in the latest command. right? But I have some few like cheat sheet which has both the combination of old and as well as new. I will share that cheat sheet with you all so you can go through it and you can understand it. There are many commands are there, many commands are there which will be there in the cheat sheet. So the cheat sheet is I think around 40 or 50 pages. It has plenty of commands, everything, whatever you want to learn in Docker, all commands are there. So you can glance all those commands, you can execute, and I can keep it that cheat sheet with you. So these are the two ways actually to do that actually. Right. Now, the first way is always, guys, whenever you want to learn any command, Docker command, always what you have to do that, you have to just say Docker hyphen FN help. So if you execute this, this is what it is showing you actually. Now, if you see it very carefully, you have a Docker, you have an option, and you have a command. Okay. Now you could see that there is something like a common commands. Say, for example, I want to display the information about the system information about the Docker itself. You have a Docker space info, Docker space version, right? And there are many other commands are the docker ps, which we recently saw, docker build, this is a old way, docker pull, docker push, docker images, docker login, logout, search, version, run, exec. There are so many options are there. So these all these informations are something like an older option actually, but still they have kept it, as I said, for the backward compatibility. They kept it. Maybe after some time they will remove many of these options, but anyhow, we have something when you execute the docker -fn help, it is showing that these are the commands are there. So it means that you can just use a docker and say info or docker pull or docker push or docker images. Like that, you can use this command. After this, what happened, right? They have added some newer stuff actually, which we call the management command models actually. We call the command models. So Docker builder space and some more options are there. We will see what are Docker builders all about. Docker build X. These are all the new options, guys, which I'll be explaining in our session. These are some of the advanced things which they have added. Docker checkpoint. Yeah, manage checkpoint. This is also some option, the new things which have been added. All these things are new things which I'll be showing you in our upcoming sessions. So Docker space builder, Docker space build X, checkpoint, compose, container, everything. Can you see here? You have image. So Docker image and say ls. Here also have Docker images we have, but this is the older command actually, the older option, which slowly we'll stop using it actually, right? So this is something which you need to be aware of actually. It means that Rajesh, whenever I want to explore anything, you have to always use this management command, like Docker and image. Similarly, like that when we are working on Docker, we will come across something as a Docker networking, Docker storages, Docker trust, Docker volume, Docker manifest, like many things are there, or Docker compose. How we are going to understand? You have to just say Docker space compose space some options. Docker space network space some option. Docker space volume space some option. Docker space scout space some options, some other options like that, right? Say for example, if you say Rajesh Docker volume, right? So if you, as you see the name Docker volume, oh okay Rajesh, this option or this after the Docker, this volume, whatever you have, this is a model or this is a management command model which is newly there. This would be related to the volume only. Suppose you want to create some volume or you want to attach some storage to an existing container, something it could be related like that. Suppose assume that I want to create some new volume for my container. So what you will do, Docker volume -FN help, like this you do and say enter. See, it will show you so many other information options actually. So you'll say that Docker volume and you will use this create actually. It means that it will going to create a volume for you. Same thing whenever you want to display any volume, existing volume, Docker volume ls. Docker prune, it means that you want to remove any unnecessary volume, you can use prune or else you can use remove. Whenever you want to inspect, Docker volume and the inspect like this. So when you're trying to do a Docker volume and -fnl, this will give you some more options. This is the only way you can learn through a command line. Or else if you feel bored to learn a command line like this, you can depend upon the cheat sheet where they will give the complete exact command, everything along with all the options. And also they will give one example also how to run this command when you are working into the system, right? That thing also they will give you. So any one of the way you have to learn, but I prefer to go with this way only because this is the best way to learn and you will not remember, you will not forget anything else. Because when you're trying to do help and try to understand it, you will be slowly understanding in a detailed manner about what these commands are all about, what are the options will be passing along this command. Many things very in detail you'll be learning because you will be struggling to create this command in the command line and then execute it actually. And that is the best way actually to learn. It is not only on Docker, it could be anything. You're learning Ansible, you learn any kind of a DevOps tools. You have to struggle to do it in the command line, or else you can go to the cheat sheet, or else you can go and check it on Google also. Say, for example, you say that Rajesh, I want to create a volume. See what it says. You have to just go to the Google. It's not that big deal. Docker, uh, Docker create new volume. See, Docker create, Docker volume create. See, he himself is giving this command, Docker volume create. So if you go through it, you will get all these options. See, Docker volume create option like this. You will get manipulations and you will see that all these options they'll give you, right? And they'll also give the example. See, Docker volume create hello. It's going to create a volume with the name hello, right? And then like you can run some image actually, and you can store all these details, everything into that hello volume actually like this. You can run the command. So these are the examples. So these are very nice way of learning Docker actually, right? Through a command lines. Am I clear, sir? So always make sure that you try to give more and more time when you're learning the commands. And anyhow, obviously, like all our sessions, whatever you are covering, every session, guy, every day will be learning, will be running or executing some kind of a Docker command. It's not like that we'll only be learning theoretical. We have to execute a lot of commands actually, and that is a good way. So till last day of my class, now Docker, you will see that I'll be executing some of the other command, right? Correct, guys? And if you see it, if you watch it, one more thing, Docker hyphen help. Apart from this, this is something like we call the model. And apart from this, you have something like an extra model. Extra is just something like a commands actually, right? So we use along with this, say for example, Docker image or Docker image import, Docker image inspect, like that also will do. Docker image inspect. So these are the some of the command options which are the options for this module also. The management command modules also, right? So these are all the commands you'll be using. So Rajesh, whether we'll be using the combination of the Docker with the management command and with the commands, yes, sir, we will be using all these commands also. And you could see that there are some other options also there, like this global options are also there. So all this combination, guys, we will be using in our command line heavily in almost most of the sessions. So it will be quite interesting for us to learn also. Say for example, I'm just saying you. So you'll say that Rajesh, Docker image is there. So I want to check what are all the other options are there. You can just do that. Docker image. And how to check it out, guys? You know very well, -fn help. See, can you see Docker image import, Docker image inspect? See, this much of command will be will come for or will be used for the image model actually. Same thing. If you go here, as I said, right? If you say Docker-fn help, see Docker, and if I say image, and all these commands are applicable. All these commands are applicable. I mean, all these commands are applicable. Where is it? Yeah, all these commands are applicable. But we need to make sure that actually what are the commands which are used heavily, right? So Docker-fn help. See, so many option commands are there, but out of which only the some subset of commands only are applicable for Docker image, not everything, right? For example, history, import is there, inspect is there, something. These are all will be used for the image. Similarly, some set of options, command options will be used for volume. Some set of command options will be used for networking like that. So how do you know that everything? Nothing, sir. You have to just say Docker network -fn help like this. Here, Docker network -, see, connect, create like this actually. Again, you will just say Docker network. You just say that Rajesh, I want to create a network actually. You will just use create. Again, after this, we don't know what is it actually. I can just say -fn help. I'm sorry, -fn help. See, it will show so many other options like this. So you can use like this. So Docker network create -d driver, and you have to specify the string, or -o map, or -fn attachable -fn aux address map. So you can use all these options for your Docker network create. It's upon our requirement. What are the options we'll be using it actually. So we will be learning when it comes to Docker networking, which is very important. We'll be learning many command line. Conceptually, we'll be learning, and also we'll be learning about the command line also. Am I clear, sir? Till here? I hope that you understood.
Yeah.
Very important, sir. All this, or else you can go to the Docker cheat sheet and then try to download any of the cheat sheet. As I said in the last session, that I'll be sharing you some very good important cheat sheet. I'll be sharing it today, or else I will upload in a shared drive. You can download from there. So today, what I will do, I'll try to upload some very good documentation on Docker. I'll be uploading some 5 to 10 documents, but don't read everything. Try to read only one document at a time. So I will also point out which is that document which you have to read it actually. You have to only study that document only, right? So yeah, you will say, sir, you don't have time for going through video only. Where will get the time for reading document? So you have to make a habit of reading, guys, actually. Okay, good, sir. Any questions so far? Okay. So, like, that's the reason what happened, guys. Whenever suppose somebody says that actually, sir, I'm very new to this, sir. I'm a non-IT guy. Okay. Uh, Sir, I'm not technically, sir. I'm not from computer science background. So these commands and all will feel I find very difficult to understand. So nothing like that, guys. Anyone can able to learn this command very quickly. Actually, it's not that difficult, right? So whenever you want to create anything, see, for example, I want to just say, suppose, for example, you want to figure out how to use it actually. Do you think that anyone have to be well educated in learning this software? Nothing, guys. It's not like that. You have to only know. You need to smart enough to find out what is the command will be in a Google itself actually. Right? For example, suppose somebody asks you, Rajesh, how to create a Docker container, Docker network, sorry. Do you need any rocket science to find it out? No, simple. Go and Google the same string in into the Google. You'll get the answer. Or else you know that there is something like a Docker network is there, and there is something like an option is there. And after that, you need to give them some networking name, right? So Docker network create, and some you have to give some name actually. Say for example, like Raj net zero, like something like that. We'll give this name. So it's going to create a network with this name actually. Similarly, somebody said that, okay, Rajesh, can you display all the volumes? List all Docker volumes. How do you do that? Is it rocket science? What you'll do, you'll know that it's a Docker volume. And if you try to do a -FN help, it will show you something like ls option. Oh, you got it. Now you have to say Docker volume ls. It will display all the volume. So somebody says that, Rajesh, okay, there is a container which is running. You need to stop the container. You need to stop the Docker container. Do you think that is very difficult? It's not difficult. So what is it actually you'll do? Okay, I know that there is something like a Docker container is there. Docker container command is there. I have to use -FN help option. It will show you some option. In that I found that, okay, there is something like a Docker container. Stop is there option. And then after that, what I do you have to give a container name. Container name, or you have to give container ID. Any one option you have to provide it so that it's going to stop that running container. Same thing, Rajesh, how do you remove the Docker image? How to remove or command to remove or how to remove the Docker image? How to build the Docker image? So these are all pretty straightforward, these commands. It's not that difficult. Anyhow, we'll be covering everything. But what I'm trying to tell over that, there's need not to be, no, you need not to say that actually that no, I'm from non-IT background, I cannot understand this command. So it is not like that, guys. It is very simple. You have to only Google it out. You will get all the answer for whatever you need it actually. Only that you should know how to search for it and how to get it and how to use it on a command line. That's all. It is not only with Docker. It's anything. Start all the containers using Docker Compose. Suppose somebody asks you, please start all the containers using Docker Compose. Is it difficult? I mean, firstly, you need to know what is Docker Compose. That is one thing. But if you are not aware of it, assume that I'm not aware of it. Okay. So, Rajesh, how to do it actually? You'll just say, Rajesh, Docker Compose, start. There's some option you have to pass -A. It'll all container will get started. So is it difficult? Or else if you Google it out, in the Google you'll get, you have to use Docker compose start hyphen A. All content will get started up. Same thing, you want to stop it, Docker compose stop hyphen A. All content will be stopped like that. So these are the command sign, and we should not feel very difficulty in understanding or using in our day-to-day activity, because you need to use it every day. You have to use it. And when you start using it, as I said, you need not to even remember also. Everything will be a part of your existing knowledge like that. Clear, guys? Okay, good. Now let us try to see like what exactly happens actually. Like for example, uh, okay. Now let us see. Let me check one more thing. Like how containers are getting created. How containers are getting created. Let us try to look into this at a very high level. Okay. So whenever we want to understand, guys, how the containers are getting created, okay, we need to understand two important aspects. We need to understand two important aspects, or two important, I can say, components, not aspects, components in the Linux kernel. Now, we know that Linux kernel was designed by Linus Torvalds, right? Linus Torvalds in 1992, he released this first Linux kernel operating system, right? And they named it as a Freaks actually, Freeix. When the Linux kernel was designed by Linus Torvalds, and when they released the first kernel version of the first kernel version, which is about 1.0.0 kernel version was released, at that time itself, or else after a little time, what happened, the kernel had some two important components, or some two important features which the kernel itself was providing it, which we call it as a namespace actually. There's a namespace, there's one component which you call the namespace, and the second was nothing but the C groups. So these were some fantastic two components, you can say that, which already existing in the Linux kernel. So this, with the help of these two components, namespace and the C groups, you can able to create something we call as a container. So containers are created with the help of namespace and C groups. Now, what are the C groups namespace? We'll shortly understand in a very high level, right? So with this only, it means that Rajesh, when I'm creating a container, say for example, when I'm running a command, Docker container run, I'll just say hello world, that first one, the first command which you execute, right? So what it do that, it'll try to pull this image, and then once the pull is done, then what happened? The Docker container is going to run a container, or is going to create a container. So how the container got created, right? The container got created with the help of the namespace and C groups. And it is very important. In some interviews, they'll ask you how this container works or how these containers are created. Can you tell me? So they'll say, you have to say that, sir, there's something like a namespace and C groups. With the help of that, it's going to create it. Okay, fine. But what is a namespace? What are C groups? Can you elaborate a little bit? So they'll go with one step actually. So you have to answer it also. Not every company will ask, I'm saying that, right? But you need to understand it. Okay. Now, to make you better understand about all these things, actually, let me take some things, right? For example, let me explain you in a different way so that we'll be able to understand it, actually. Now, for example, assume that we are having an operating system, right? Suppose, assume that I have a virtual server images, not virtual, virtual, yeah, server. Mm, what is that? Virtual machine, right? Virtual machine image, not server. Ah, why I'm not getting? Uh, oh my God, what is it, sir? Um, what is to always give virtual? what is it, sir? Virtual machine. How come, sir? The search is not. I need to get a server, hardware server, right? Physical server, something. Physical server images. Okay. Yeah, this is something I needed. Not this one exactly. Yeah. Okay, this is my server actually. This is my server. Consider that this is a server and this server has Windows operating system, right? Now the question comes, Rajesh, in this Windows server, right? You have some disk drive, right? Right. So, for example, disk drive image. You have a disk drive. This is not but a disk drive. This is a drive, disk drive you have, hard disk you have. So through this hard disk, what you will do that you will try to create some drives actually, a physical drive. So this we call it as something like a C drive. Okay, if you want, you can even create many partitions and you will have something like a D drive, right? It depends upon your disk space, right? You can create a number of drives, right? This is not but the hard drives, right? These are nothing but the hard drives, right, guys? Do you agree with this? And these are nothing but the drives actually. It means that your whatever the physical drive, hard disk is there, you are divided or you created into partitions actually, and these are nothing but the disk drives we say, or partitions we can say, right? Partitions we say. Now, this disk drive is nothing but this is nothing but drive where all your information about your operating system, file system, all this information will be there in the drive actually. Particularly in the C drive. So this is a C drive where what happened, right? Your operating system image will be there in this C drive. D drive is something which will be free drive. If you want to store any other information, you will be storing in this D drive, right? Like I'm just taking, you can have a number of drives based on your hard disk capacity, right? Similarly, what happened, right? You have one more machine, the same server actually here, one more server you're having. So here what happened, right? You will try to install Linux actually. Linux is an operating system which you have in this machine. Correct, sir? Now in this machine, right? If you take the file system, if you take a file system, it is something like a, I can just say it's something like a folder. I'll just take a name folder. Folder image. Yeah, this is something like a folder you have. You have this folder like this right here, and this folder will be, the naming convention of the folder will be something like a slash. It will be slash. It means that the Linux operating system will manage all the information about the Linux operating system, everything into something like a slash. So you can say that slash is equivalent to the C drive partition. What we have C drive in Windows, right? The same thing in Linux, it is actually slash actually. So slash, it means that it is a folder actually. It's a folder structure, it's a folder. So, and the naming convention is slash actually. Here, even this is also like a folder only, but we call it as a partition. Here also we call this as a partition, or it's a disk space, and the disk space or the disk is identified with a slash, whereas here the disk is identified with the C drive actually. Am I clear, sir? Right? Now, what happened, right? This slash is nothing but this is something like we call it as a root file system. What is it? We call it a root file system, right? Right? Root file system. We call it an RFS, right? Okay. Now, or else let me do one thing. I'll try to do control. I don't need this. Let me take what is it actually? Linux file system hierarchy. Yeah. So I want an image actually. Okay. Yeah, this looks good actually. So this is what the image guys actually. I mean, this is the image and this is nothing but the file system actually. So if you take in Linux side, This is what the file system you have. So this slash is nothing but this is what I would say that it is a root file system, RFS, root file system. So now the question comes, Rajesh, in this Linux actually, in the Linux, where the operating system image will be there, it will be a part of the slash only. Where exactly the information about the operating system of Windows will be there, it will be there in the C drive. In some specific folder, in some path, okay, you will find that there is a Windows operating system will be there actually. Right? Here in case of a Linux actually, usually it will be there under the boot directory. Right? If you go to here, if you go to our playground and if you try to go and just say cd slash and say enter and say ls, can you see something as a boot drive? Yeah, where is it boot actually? You could see that. They have removed it is there, it is not there. They have removed it actually. They are not showing it, but it has a boot drive actually. Like this, the boot drive will be there. If there, it's not there, but again, I don't think, okay, let me do this. Let me log into this server, Docker server, which I created. Let me copy this public IP and open the terminal. Okay. And try to get into the, what is it, sir? Try to get into the downloads, right? Where you, I think you have that a file by name. Yeah, N California, right? So I'll just say SSH-I N California, and then like say Ubuntu at the rate, give the public IP. This is my Linux machine, right? And it's a Ubuntu Linux. So I'll just try to log into this server. Now, if I try to do cd slash and say enter ls, can you see something like a boot is there? Yes, sir. So if you get inside the boot and say ls, can you see something like init image and VM Linux image? This is your actual kernel image or the operating system image. This and this together, it is there in the slash boot directory. So if you go back to the figure here, you go back to the diagram here, under the slash, there's something like a boot directory there. That boot directory has your file system, has the operating system image information. That is the Linux kernel, and there's something init image. Both the things are there under boot directory. So this is a specific folder where they'll try to keep the bootable file image or nothing but the operating system image itself, they'll try to keep it actually. Right? That's how it's been designed. So this is not but your the whole file system structure now. Right? The extended file system structure or ext3 or ext4 file system structure of Linux, right? This is how it looks like actually. Am I clear, sir? Now, the thing is that what I'm saying means actually that, Rajesh, for this also, where this is placed, so this is placed in the disk only, sir. This, the whole root file some slash, it is placed on disk only. So this slash, it is created in your disk hard drive only, it is getting created. Clear? Now, you might say that, okay, fine, Rajesh, it's good only. I understood whatever you're saying now. Now, assume that, Rajesh, can I have a disk for, 1 second. Let me try to, I'll try to keep it here so that, yeah. Hmm? So now you will say that, Rajesh, can you see there's something like home is there? Yeah, home is there, correct. So, Rajesh, can I have a separate drive for the home? Yes, sir, you can have it actually like this. So you will take this hard, the same figure, you will add one more disk into your machine, right? Where what happened, right? You can create a separate home directory you can create onto the disk itself. It means that this disk will have only slash home actually. It will have only slash home or just a home actually, right? So it means that this disk, everything will be inside, connected inside the server only. So somebody will ask, Rajesh, can I have a separate disk for the var? Yes, sir, you can have a separate disk for the var also. This provision is there only for Linux guys, not for Windows. Windows doesn't have all this provision. Only you have for Linux only. We have Linux or Linux or Unix. So you can have a separate drive for slash var here. So why we are keeping, because the slash var is a directory where all the logs, important logs are placed. All logs, all the logs, all the system logs and application logs are stored under slash var directory. So that's the reason what happened, right? You will tend to keep a separate drive for it, where this var will be mounted onto this disk, and what are the data which you're writing into the var, that will be everything will be written into the disk only. So you can have a separate disk like this also, and all these three disks will be part of the server inside. There will be three spaces will be there where you can go and plug in. You can push your like drive, and you can do it. So during boot up time, what happened? Right? As soon as a boot up, what happened? This hard disk will be initialized because it is a root file system. Once it is initialized, once this operating system is up and running, this file system will get initialized. Automatically, this drive will be mounted onto the where. This drive will be mounted to the home directory like this. Literally, this hard disk, everything will be mounted onto the home only. This disk will be mounted onto the where. So why I'm saying you, because that I'm using some word known as a mount. So that's the reason I'm explaining all this, because mounting is something like mounting an external disk, external file system disk onto some directory or a folder. We call it as a mounting. So some external file system you are taking and you're making to the part of an existing file system, that we call it as a mounting. So why I'm using this mount, why I'm telling you all these things, because guys, I have to explain about what is this namespace. So in that, one of the namespace is the mount namespace. That's the reason I told all these things. So here what happened, you have a different disk for different drives, you can have it, but in case of Windows, it is not like that. All the data will be stored in the C drive only. Your logs will be stored in the C drive only. If you're having a home directory also, it will be there only. If you're having something like a boot up file or nothing but the information or the operating system image of Windows, that will also, everything will be there in the C drive only. We don't have this concept of having an external disk mounted onto that particular partition. You cannot have in case of Windows. Am I clear, sir? Till here, are you okay? Sir, is it fine, sir?
Yes, sir.
Yeah. Now the real trick comes. What is the real trick? Okay, Rajesh, now I got it. What you're saying it. Fine. Now we'll take one more thing. I'll open one more. And I will try to have. Okay. I'll try to copy this. I need this server image. Yeah. I have this server now. Right. And you know that, Rajesh, in the server, I consider that this is a Linux machine. Okay. Linux operating system where you have installed Linux. Now, this Linux machine has the file system, or not, but the disk file system. Where is it, man? Yeah, this is a folder, as you said. Okay. So this is a folder. Here, what happened, Rajesh? This is a folder which is not, but it is a root file system, which is not but the slash partition. Okay. So it means normally you're having like this. Now assume that in the same Linux machine, okay, you have a Linux operating system. On top of Linux operating system, OS, OS. Here, what is happening that on top of it, what you're doing that you are installing the Docker. You're installing Docker. Your Docker is installed. As part of a Docker installation, Docker daemon, Docker client, everything will get installed. Now you say that, Rajesh, on top of it, I'm actually creating a container. This is the container, zoom that. This is the container, right? This is the container which you have created it. So this is the container which you have created. This is a container created. Now, Rajesh, whether this container will also have a file system information or the slash? Yes, sir. It will also have a file system information like this. Like this, it will have. So what happened? The Docker container itself have its own file system information, file system which starts with a slash only. Am I clear, sir? Is it fine, sir? It means that the Linux operating system has its own slash, which is number the file system or nothing but from where the whole Linux operating system works. Similarly, when you're creating a container, it also has its own file system. So while creating it has its own file system, it also starts with slash only. For the Linux container, it will treat that, okay, I'm working under the slash or I'm having a file system. But actually for this Linux machine, right, when you're creating container, where this file system will get created or where this file system will be reflecting, this would be reflecting under something we call it as a slash var lib docker. This is the path, guys, where the file system will get created for the Docker. So here what happened, this is the home directory for the Docker container. Under this, there is something will be created. So with this name, with this, assume that this container and something is Rajesh container. So there will be something folder named Rajesh container like this. Inside this, inside this, it will have that file system information. Just try to understand at the very high level. So for the Linux, for the base Linux which it has, right, it is actually doing an operation onto this container, right, with the help of this path. So it is trying to refer to this path. But for the container, what it is happening, guys, it is actually doing all operation to the slash only. But in turn, actually what is happening that it is doing onto this path actually. Am I clear, sir? Right? So it means that why I'm saying you all these things, because that you have to understand how things are working. Like whenever this Docker daemon or the Docker is creating a container, during the container creation, it also creates one file system inside it, which is it's a small part of slash. So now this container will treat that, okay, this is my root file system. How Linux kernel is treating a root file system, similarly, the Docker container has to create a root file system. So that is actually who is doing all those things. Your container Docker only is doing it. Docker daemon, or we call it a lib container, that is actually doing it inside this container. Okay, fine, I got it. Now, okay, now, okay, let me do one thing. Let me show you something here. So this is my Windows machine. If I go and if I try to open a task manager in my Windows machine, see, this is my task manager, guys. It means that it will show you that so many processes are running in my system, and it will show you all the details about how much each and every process is using all these different like hardware resources like CPU, memory, disk, network. Every process will show. So this is something like we call it as a process tree, a process tree, right? So for every application, whenever the application is getting executed, it also needs an information about under which process tree it is running or it is getting executed, or what is a process tree actually, right? What's a process tree, right? What is a process tree? Now the thing is that, guys, in case of Linux, right? In case of Linux, this is the Linux machine. So in case of Linux also maintain something we call a process tree. And for every process in Linux, actually, it has something known as a PID, process identification number, or process ID. So whenever the process are getting created, or whenever during the booter time, when the operating system comes up, there will be something, there will be first process will get created, and the process ID is always one, actually. Now, once the process ID one get created, which is not but the parent process, later there are so many processes will get created like this. Like PID 1 is the first process got created. Later, so many other processes will get created, like process PID 2, PID 3, PID 4, PID 5, PID 6, like that. So this entire thing, it looks like a tree structure. Hence, what is happening that this is something like it's a process tree, we say. It's a process tree. Now, for example, if you go to the Linux, if you try to execute the command, oh, I think I lost this connection. Right? If I try to execute a command ps3, see, it is showing you the process table like this, or the process tree like this. So it means that it has its own, it maintains its own process tree like this. Or else if you execute the aux command, see, it is showing a process tree. Can you see here? That's a big process tree. Now, can you see here? The first process which we created is a process ID 1. And the process is that, but the init process. Init is the first process which creates a Linux machine. Right? So similarly, if you go to this task manager, here also so many processes are getting created. But we don't know which is the first process in Windows operating system. But some process get created. That's the first process actually. Right? That's the first process. This is a process. There could be one process which is the main process or the parent process. Rest all of the process which have been there are the child process, we say. So this is something like a tree kind of a structure which it maintains internally. So the same thing, man, whatever you are having this tree here, process tree here, right? PID. So the same thing inside the container also it maintains like this actually. Like this it maintains. Inside it actually it maintains like this. Here also you will see that there is a process tree will be there, which will be there running actually. Say for example, if I try to run here, the PS command here, in case of Linux actually, and say enter, see it shows me, it's showing me the tree kind of a structure. It's showing me the tree kind of a structure. Or else if you want everything, you can execute a ps-aux, pipe it to less like this. It will show you all the process with us. See, it starts the PID1 and so many processes are there actually. Right, guys? Right? Same thing here also. As I said in the diagram that here also some kind of a process tree will be created. Here also there will be a PID1 will be there. Right? PID1, it starts the PID1 and many other processes will be there as part of this inside this container. Right? So why I'm saying all these things? Because that, as I said, that I'm talking something, I will be discussing something about the namespace. So that's the reason I'm discussing about all these points. So here, guys, what we are doing that here we are trying to, like we are trying to understand what, like how things are there in inside the container. Okay, now come back to here. So Rajesh, I have a Ubuntu Linux which are logged in fine. How to verify what are the users you are having in a system? So you can do a cat of slash etc possibility and say enter. If you open this file, it will show you which are all the users are there. Like here, you could see that Ubuntu user is there, EC2 instant connect user is there, many other users are there. These are the users which are there in a system. So most of the users are system users. Some of them are normal user, like Ubuntu is a normal user, but most of them are system users, like root, daemon, bin, sys, sync, games, man. These are all system users, we say. It means internally the system or the kernel will use this user accounts, right? Whereas a normal user, Ubuntu is one normal user is there, which is there, right? Tomorrow, if I try to create like sudo, right, user add user or user add whatever, Rajesh, right? 123, 123, enter, right? See cat of slash etc pswd. See now recently Rajesh had got. See Rajesh is a normal user. Ubuntu is a normal user, right? And rest all other users are system users. We said. So here what happened that I'm getting some users actually. Some users I'm getting in my Linux machine. So Rajesh, does the same user information is also there inside a container? Yes, sir. So here what happened that you are having some users actually. So here you are having some user information. In case of your Linux, the same thing here, even it is there even here also. Inside your container also, the user informations are there. Okay. Now, what are all this information which you are creating? So, whenever we are trying to, guys, whenever you are having an operating system, the operating system has many components. Like, for example, the operating system has an information about the user accounts, the information about the process tree, the information about the file system structure or the storage or the file system, right? It also has information about your networks actually. Say, for example, in the Linux machine, in this Linux machine, you are having basically you have two networks actually. So if you try to understand, like for example, if I try to do IP addr, can you see here, guys? There is something like a loopback is there, and there is something like a EXNXO is there, and the IP address is 172.31.17.25. This is the IP address of your ENXO interface, network interface. Similarly, you are having a loopback, which is nothing but 127.0.0.1. Okay, loopback address. How we will going to get, because in your motherboard, right? In your motherboard, you have a chip is there actually. A inbuilt chip will be there. That is nothing but the network interface chip will be there. With that help of that, you are going to get the loopback address actually. And later, if you want to connect any external network card, you can connect it, and then you will get one more separate network identifier, which is number ENXO. Sometime you will get the name with the name ETH0 or ETH1. Here in this case, it is getting ENX0, and you will get an IP address for that actually. Right. So here you are having two network interfaces actually. Similarly, because we installed Docker into this Linux machine, you will also get one interface as a Docker 0. So that is a Docker interface actually, right? We will discuss about this later. So time being, what I'm trying to tell that there are two network interfaces are there, loopback and ENXO. So if you go over here and I'll just say virtual network card image. Yeah. Right. Like this. So this is something like a hello loop back will be there. Hello interface. And here in our case, I'm saying in case of Linux machine, it is showing the ENX0. I will take with this name only. But usually you will have with the name something like ETH0 or ETH1. Something with this name will be there. So in this case, what is there, man? We will consider with this only. Here it is there, I mean ENX0. Anything, it could be any name. ENX0, like this, it is there actually. So this is a network interface card. So this network interface card are connected to your to a server actually. With that itself, you're going to get the IP address. So Rajesh, when you're creating a container, do you have this network interface? Yes, sir, we'll have the network interface also. Like this. Like this network interface will be attached like this to it. And it depends upon your requirement. It might be one or two. There won't be more than one or two network interface card will be there. So if you try to get inside this Docker container, you'll be able to even see the network interface also. So this will be something like a loopback, LO will be there, loopback, and this will be something like ETH0. Am I clear on this till here? So guys, do you have any doubts? Now, how this container got created? So now here you could see that. So to understand this, we need to understand C groups and namespace. So what is namespace? Namespace creates virtual isolated isolations. Like for example, here what happened, right? In case of an operating system, you have a process tree. Process tree is there, right? The same thing what is happening, that process tree is nothing but we call it as a PID tree. Sorry, we call it as a PID tree. So virtually PID tree will be created inside the Docker container with the help of PID namespace. So there's something a PID namespace. So Docker has that lib container, right? That lib container, right? The lib container will use the namespaces actually. There are various namespaces are there. One of the namespaces is not but a PID namespace. So it's going to create a PID namespace inside the creator while the content is getting created. While the content is getting created, this lib content is going to create a namespace which we call a PID namespace. I'll just say namespace, I'll just say NS. Shortcut I'll say NS, right? So we're going to create. Same thing, Rajesh, here, if you come here, there is something which is something we call as a mount namespace. Mount namespace is basically it is used for creating a virtual file system, actually. Virtual file system or disk actually, or the disk drive, like that actually, right? Same thing, you are having something like user namespace. It means that you need to have a user namespace, user account should be created, right? It's going to create actually. Similarly, you have something like a network namespace, right? Am I clear on this, sir? Network interfaces or network namespace, right? Am I clear, sir, till here?
Yes,
Yeah,
sir.
Rajesh, I
So
got a question.
all these namespaces are getting created while container is getting created. And who's going to do all the operations? The lib container will do all the operations. Yeah, somebody has some questions. They were asking some
Yeah,
questions.
Rajesh, so you were talking about the network interface card, right? And then I also had you talk about like a virtual one for the Docker container. So does it mean, the hardware itself, the computer, right, has its own NIC card? But then when you say virtual, does it mean when you create the Docker container, you can just attach more virtual NICs to it?
Yeah,
Because
sir.
that's what you said.
These are all the virtual NICs only, sir. Virtual NICs only. But what happened,
Okay,
right
so
here? What happened by default? Like for example, one virtual network interface will be given for your Docker. Later, if you want it, you can create n number of containers by using a Docker network create. By using that command, you can create n number of network interfaces which you require actually.
okay, so what do you use the virtual interfaces for?
Come again, virtual interfaces, sir.
Yeah.
Virtual interfaces, nothing but these are the virtual interfaces, sir. Whatever the mount namespace, user namespace, network name, these are virtual interfaces which it creates actually. Ultimately, all these are namespaces only. See, whenever you want to run any application in your operating system or in your machine, so that application always checks for that, okay, on which file system I'm running, what is the process tree which is running, what is the disk which is available, what is the network interface which is available, right? And what is the storage which is available. It try to checks all the information whether all this is there or not. Then only that application will get executed. So it needs an environment to execute that program, right? So application always needs an environment. So for it, it needs a network, it needs a storage, it needs some kind of a library if it requires to run, or if it is depend upon some libraries, those libraries are required during runtime. Those libraries will get loaded so that the application which is running, it needs that external library or dependent library. So that also your operating system will provide. It checks that under which shell I'm running. Okay, there's a bash shell, or under which user account I'm running. So an application, whenever it want to run, it needs all these resources it needs. Who provides it? Your operating system provides it. Now, the thing is that now when you're saying, Rajesh, I want to run some application inside a container, which you call something like a boundary, what and all it needs, sir? Sir, it needs the same thing the way an application runs in operating system, the same resource it needs here also. It needs a network, it needs a storage, it needs a user, it needs a process tree, it needs a network interface as everything it needs. Then only the application will run in the inside a container. Otherwise, it will not run.
Yes, please. My question is like, for me, when I understand the network interface card, right, it's something that is part of the computer to give it like
Okay.
internet connectivity, something like that.
Right,
Like,
right. I'll come here. Yeah, I'll see. Now what happened, right? You are having a network over here actually, right? And what happened that your system it will be and your operating system will be connected to this network actually. Similarly, what happened, right? Whenever you're having a network interface, here also what happened, right? Your Docker container itself have its own network actually. Network. And this network, this virtual cards, which is attached or which is there as part of container, this should be connected with this network actually. This is something like we call as a Docker network. This is your nothing but your local network which is connected. Am I clear, sir? So these are two different networks. So it means that Rajesh, inside my operating system, I have Docker installed, and with the help of the Docker, I am creating a container because even this container is also a part of my same system only. But you are having two different networks actually, right? Yes, you can have a number of networks, right? So this is a local network which you are connected to your machine, and this is the network which has been generated automatically when you're creating a container. So from my host operating system, how I can talk to this container which is having a separate different network? Yeah, we can even talk also. We can even communicate also. So something you need to understand something as a port forwarding. Whenever you want to communicate, you have to use something as a port forwarding, right? So it means that Rajesh, some application is running inside a container. Someone who is sitting outside, he want to access this application which is running inside the container. How we can able to access it? He has to first enter inside this local network from this net into this network, and from here, right, the request will be forwarded to this container where that application is running. So this whole thing which we call the port forwarding. So, and of course, how the communication happened, because that guys, here what happened, you are having a local network and you are having a Docker network. Okay. So we are having different types of network. We call it a bridge network. We have an overlay network. By default, whenever a Docker content is getting created, we will get something as a bridge network. It means that in the bridge network, what happened, whenever any kind of a packet or any kind of request comes, you can actually even pass on that packet or that request or packet even to this Docker network also, because it is under bridge. So what is overlay bridge? What is overlay and network and all? We will see it later, guys. It's a big topic actually. We have a dedicated topic for Docker network where we'll be discussing all those things actually. Dan, are you okay with this, whatever I said so far?
Yeah. Thank you.
So don't worry, we will be covering. It's a good question what you asked, but we will be covering all these things in a dedicated topic. I think it will come after 7, 8, or 10 sessions actually. More than that. After 10 sessions, you will come across with something as a Docker networking. It will take 2 sessions, guys. I think 2 hours, 4 hours. In 4 hours, you'll be completing the whole Docker networking concept. Same thing, Docker volume, like in almost like 2 or 2, 3 hours, I'll be covering Docker volume like that. Docker Swarm, 4 hours like that. Right? So many things are there we'll be covering, guys, in this area. Okay. 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 Now, okay. Now, good. I think I lost this connection. Huh? Oh, man.
Thank you here.
Yeah, saying something. Man.
Oh.
I don't know how to. I have to increase the timeout. Otherwise, it will keep. Okay. Now, so some interesting we'll try to understand now. Okay, good. What is it actually? Okay. I don't think I'll try to go here also because my playground is running, right? You can even refer to this playground also. Where is it? Yeah, this is active actually. And one more thing, if this playground, whatever you have launched, right, if it is inactive for 30 minutes, it will log off actually, and you will not be able to utilize that 4 hours. So per day, 4 hours of this Docker playground will be given for every user, right? And if you are inactive for half an hour, more than 30 minutes, it will get automatically log out. You will not be able to again get a new session. You will not get that actually. If you want to effectively use it, actually, you have to keep working on the system. And for the next 4 hours, you can happily work whatever you want. So whenever we are learning any command, I need not to have any Linux machine. I need not to go and install it. Directly, you can go with the Docker playground, and then you can launch this, and then you can work on it. So only to learn the commands actually, not like concept. When you're working on something like, then don't use this thing actually, right? It's not. You have to always go with the machine where you have installed Docker, right? But for practicing commands, you have to always go with the playground actually. Initially, you play with this playground. Later, we will see. Later, you have to switch into the machine where the Docker is installed. Am I clear, sir? Now, now what I'm saying here that actually guys, this is my Docker machine, or even this is my Linux machine where I have launched the Linux. Now assume that I want to check whether the Java is installed or not. How to check it? If I'll say Java -version and say enter, it says that the command not found. Same thing here also. If I go to the playground, here also Java is not there in my operating system, right? So if you see the diagram, I'm just saying you here in this Linux machine, do I have a Java here? No, I don't have a Java here. Okay, fine. So now what I will do that actually I'll go back to the container here. Okay, I'll run a command docker container run -it. Let me give something open jdk :11 and then say don't worry about this command, guys. As of now, don't worry. Just see what I'm doing it /bin/bash and say enter. So it was trying to download an image, open JDK with the version 11. In that you are actually you are trying to have an image of the name OpenJDK 11 version, Java 11 version actually. And what is doing that? It is I miss interactive miss T miss terminal. You're trying to create a container with this image OpenJDK. So initially you didn't add that. It is trying to connect to your hub.docker.com, which is not but your public registry, right? And from there it is downloading. And afterwards, what you're doing that once the container get created, you need to log in inside this container. Whenever you want to log in inside the container, you have to use this IT option. IT means interactive, T means terminal. You want to get the terminal means you have to log in means you have to provide, which is a shell /bin/bash. Can you see it? Now you could see that, guys. It is Ubuntu at the rate. This is my local machine. But when you try to run this command, you could see that actually that you have actually logged in inside this OpenJDK 11. Now you are inside your container now. Can I check if Java is there or not? Yeah, I'll say Java -version. Can you see here, guys? Java 11 is there. It means that as part of this diagram, the Java is not there in your Linux machine, but the same Java is there inside the container. So when you have inside container, it is need not to be that your Linux machine should also have, or your Linux operating system should be installed with a Java. No, it's not required because inside the container, whatever you're running that application, say for example, if you're running a Java application, you need a Java, man, Java Open JDK to be installed. Yeah, you can actually incorporate in your image itself about the JDK. It means that Open JDK can be installed. It will be there inside the container. There is no need to have inside your, what you call, inside your Linux operating system, right? This is the one difference which you have seen now, right? Good. Now,
Sir, here the OpenJDK application images you downloaded, right? Here, which Linux flavor this image will use?
no, it is not using any limit. This itself is an image, sir.
Yeah, that's fine. Here, the interactive mode, you logged into one of this Linux.
Yeah, it might be, we will see it. If you try to dissect this image, it might be using Alpine image or Destroli's image. A small operating system Linux image, which will be using. On top of it, it has installed a JDK 11, and then like somebody has built this image and it has given it. Now, if you try to go here, and if you try to go to hub.docker.com, and if you try to search for this image, what is that name, sir? Open JDK colon 11. Yeah. See, you got this. This is the official image. If you go to this image, I will not tell you all the things. And if you try to dissect this image, right, this is open JD. If you try to dissect this image, you will see that it has some kind of a base operating system image will also be there. So it could be an Alpine image or it could be some other distro-less image will be there. So what is that? We will see all those things later. Don't worry.
Okay.
Am I clear, sir? Now what happened, right? You are running this container inside. Okay, fine, Rajesh. Okay. Now I'll do one thing because I'm inside a container, no problem. Or else I'll do one thing. I'll just say exit out. I'll exit from the container. I've exited out from the container. Now I want to check what is the user accounts which are there. etc possibility. Can you see that? These are the users informations which are there in my Linux machine. So if you go back to a diagram and try to understand, this is a Linux machine. When I try to execute the cat etc password file, what I've executed here, I'm able to see these are all the users which are there as part of the Linux operating system. Yeah, okay. Fine, I understood, Rajesh, what you're saying. Now, if I get inside the container, let me run the same command again. Docker container run -it open JDK colon 11 /bin /bash. You got inside the container. Can I use the same command, Rajesh? Cat etc password file. Enter. See, you have the users. So, Rajesh, so is this user, whatever it is displaying, is the same as this one? No, right? This is totally different and this is totally different. Oh, it means that inside the image also, you have an information about the user account. So is it not matching, guys? According to diagram, inside the container also, you have information about the users. User information should be there. So this is nothing but how you got it with the help of a user namespace. Right? Okay, good. Any other things, guys, which you can learn? Yeah, we have to understand, sir. Many other things. So you might even ask me the question, Rajesh, suppose there is an Alpine image at that time you did, right? Yeah, here, if you go here, if you go inside this Docker playground, yeah, here, Rajesh, if you say Docker image ls, you have an Alpine image. Rajesh, I want to get inside this Alpine image. Yeah, sir, no problem. Docker container run -it Alpine space, because it is not bash, it is sh actually, it's a bound shell. That's what you have to give sh and say enter. See, you got inside your Alpine image actually. So here inside the Alpine image also, if I try to do cat of etc possibility file, see, it will show all the usernames. Right, sir? So in case of OpenJDK, what we observed actually, in case of OpenJDK, we observed that the OpenJDK has the Java information or the Java is installed here. Whereas here in our base operating system or in a host operating system, there is no required for you to install Java. Similarly, suppose that Rajesh, I'm going to create one more container like this. That containers, it requires Python. You are running a Python application inside the container, right? That Python is dependent upon whatever the Boto3 library, whatever it needs, or else something like a Django, whatever it needs actually. It needs, or else it needs a Flask actually. So whatever. So do you have to install the Python Boto3 Flask here in your host operating system? No, sir, it is not required. You don't need to have anything installed over, because these are all part of your inside the container, whatever the software or the server, application server, or else what are the dependencies required, everything will be part of an image itself. That image itself is getting loaded when you are trying to run a container. When you're trying to run a container, the image, which has the information about all the things, it has a base OS, it has a dependency, it has a library, and all the commands, all those things will be loaded as part of when you're running a container. So it means that the host operating system need not to have all this information or need not to have all those software installed in it actually. That is not required. So this is what one of the advantage, guys, which you are seeing it, because it means that suppose the developer has developed a microservice and he has converted that as an image, right? And he will try to run that image and try to verify and test it. The same image is going to give to the tester machine testing. The tester will take that image. There need not to be any separate configuration. He need not to do anything in the server or in his local laptop. Only one prerequisite requires that Docker need to be installed in his system. That's all. And then he'll take that image, whatever the developer has given, and he can able to run it. So it means that it is a platform independent. You need not to disturb any kind of a platform or operating system for your Docker to run or for your image to run. You need not to have any separate software to be installed. That is an advantage what you're going to get when you are moving into the containers. Am I clear, sir? Dan, Chanakya, did you understand whatever I said so far? So what is an advantage? You have to tell the same in an interview. What you have to say that, what is an advantage you're seeing in a container when it comes to the virtual machines? So in the virtual machine, what happened, right? You need to install all the software, whatever it is required, right? And then like what is happening that if you're after installing the software and everything, suppose assume that developer has its, assume that the developer has its own in his local laptop. Okay, he has built a Java application. He is building a Java application. For the Java application to run, he has installed the Java 17 version, right? And he has installed the Apache Tomcat 11 or 10 version or whatever, right? And many other dependency, he has installed the softwares. And finally, what happens, he has developed that Java application and he's running in his laptop only. Okay, so this Java application, whatever the Java hyphen, whatever that application is, right? Java hyphen app, hyphen 1.0.0.var, something or jar, whatever. This is the jar file he has created. So now what happened? He is a developer. He's a developer who has its developer's laptop. It's a laptop where he has configured everything and he has built everything and he has made this application to run. Now the problem is that he will give the same jar file to the testing engineer. Now tester, what happened? He is also having his own laptop actually. In this laptop, what he has did means he has installed the Java 11. Java 11 is installed in his laptop. He has installed the Tomcat 8 or Tomcat 9 version. Okay. Some dependencies are missing. Which is not aware of it actually. Dependencies are missing. Now the question comes that, guys, whether when he takes this jar file, when it's trying to run, when the tester is trying to run his laptop, do you think that the Java application will run? No, it will not run at all. It will not run. It will fail it actually. So then what happened? The same tester is going to request the developer, right? It is failing, what I need to do. Then the developer will say, tell the configuration man, what is the software installed? You will say that I have installed Java 11, Java. No man, your application runs when it is Java 17. So there is a platform dependency is there. Platform dependency that the same kind of a software stack is required even in this machine also to make that application run. And if there is something missing, definitely your application will not work. So it means that before you run an application, you need to have a setup all this dependency. Then only your application will run. Otherwise, it will not run. So it means that the same platform is required everywhere. Wherever you run, you take into 10 machines. In the 10 machines, you need everything. But assume that the same thing, what happened, right? You are converted this application as an image, as a Docker image. Right? You run as a Docker image. You converted this application into the Docker image. You converted the machine, this application to Docker image. Now what happened to run this Docker image? What this developer will do, he will try to install a Docker here in his laptop. That's all. Once he runs a Docker, what he will do that he will try to create a container with the help of this image, and that application which is converted to the image, right? That will happily run in this container. Now, can I give this image, guys? Can he give this image to the tester now? Yeah, he can happily give this image, right? Now this tester, he doesn't need all these things, no dependency, nothing. There's only one prerequisite. What is it? Again, the tester's laptop should also have to be installed with Docker. Docker should be there installed. Then what happened? He'll try to download this image and happily run that image as a container, and he can do whatever the testing he wants. So here, whatever the platform dependencies there, right, that has been rid of now. So this is a greater advantage which you are getting, like when you go into the containerization. So earlier what happened? You had some issues with the virtual machines, right? Because virtual machine you have to do a separate setup. Now all those things are not required. All those dependency setup will be a part of the image itself actually, and that will be a very light image. And it will be very lighter image, light in size also very small, and you can happily run it very fast. Here what happened, right? Whenever you want to stop the service, stop the application, start the application, or some kind of a service will be there, like Tomcat will be there. Start the Tomcat service, stop the Tomcat service. It will take its own time to start and stop it. So it will take some amount of time to get started and stopped. When it comes to the Docker, right, starting the Docker or stopping the Docker is within a fraction of a second. With that, you can quickly start the application whenever the user needs it, and you can even stop it also when you doesn't need it actually. Start and stop is also very, very faster compared to what you see in the virtual machine. So these are some of the advantages what you will see in the container technology. Am I clear on this, sir? I hope that guys you understood it. Done?
Yeah, yes.
Yes, sir. Please go ahead.
Yeah, good. Now what happens is, now what we are trying to understand that how this container is actually working, how container works. That's what we are discussing so far. I thought I will finish it off, but it is going. So what are the following, sir, what are the observations, sir, we did? What are the observations we did from manual execution? Uh, what are we saw it actually? So application requiring softwares, what is it, like Java, need not to be present on the Docker host. Docker host means our Linux machine, right? Our Ubuntu Linux machine. Our Linux machine where Docker is installed. I'm talking in the machine, right? If you try to see the diagram, just to make you again understand, in this machine, I'm talking about in this machine, I need not to have any Java at all. Okay, so where they are present, sir? They are present in the container. Right? Users on the Docker host, and the container are not same. Right, sir? So we already checked it, right? Or not same. What else we have? One second, let me see the diagram. User, okay, process tree, yeah. The process tree of Docker host is different from process tree of container. Right? We already saw that, right? If you execute similarly, what happened, right? If you try to run sorry, I think, yeah, here, I mean, inside it, right? If you try to run a df-h disk file systems, you could see that all these file systems, right? What are the file systems which are mounted, right? So I'm inside this Alpine container, guys, right? I'm inside this Alpine container. So inside this Alpine container, I'm just seeing that which are the disks which are been mounted actually, right? Now, if you go back here and if you try to go and you try to go to the Linux machine here. So if I try to run a df-h here, right? This is my Linux machine. Can you see here? The disk file system are completely different here, right? Compared to here, both are different here. Here you could say /dev root /dev xvda60 there, but here you could say /dev sdb is there. So disk representation is also different, and the other different file system which has been mounted, everything is different over here. So what you are concluding that here, Where is the notes, man? Yeah. So the fourth one is nothing but mounts, the file system mounts. File system mounts. File system mounts in the Docker host are different from mounts in container. Right? Similarly, even we saw the network also, right? If we try to execute IP-ADDR here, it is different here compared to here. IP-ADDR. Right? Correct, sir? Am I clear, sir? Okay. Okay. Now, here what happened, right? Here, if you try to see it actually, whatever we saw, right, Dan, this one, whatever we saw, this is nothing but your virtual Docker network. Virtual Docker network. This separate network will get created actually. This we call the virtual Docker network.
Yeah, Rajesh.
Okay, sir. Same thing with the disk also, sir. Like whatever we are having a disk, right? The same thing here also. The disk is different. I think to make it complete, let me even try to take the image out of it actually. All disk image. So here also, whatever the disk we are having, I think the disk what we are having here as part of this Linux machine, right? And here the same disk is different here. Like this. Right, sir? Okay, now one final thing, then we'll stop it. Okay, I thought I thought many things, guys, today cover, but unfortunately I couldn't cover it. Even though we are discussing so many things, right? Still, I feel like okay, I've not covered any much actually. Okay, so one final thing, then we'll stop it today's session. Yeah, Dan, you had something to ask?
No, I already asked you. You answered.
Okay, great. Yeah. Now, good. Now, if you go back here into your container, or I means your Docker playground, or I'll go here. Okay. I will exit out. Okay. Now, assume that actually, like whenever you're creating a container, you have to give a container name also. Say, for example, if I try to run this, like for example, if you try to run a Docker container uh, run -it, you can just say -d also, detach mode, alpine, like this, ALPINE, and say enter. It creates it actually. When you try to do a Docker container ls, you could see that your alpine is up and running. But right, how this container is identified by a user, it will identify with the name. So you could see that there's something like a friendly, I guess some default name is given. So who is giving the name? Your Docker itself or Docker daemon itself is giving a name, arbitrary name it is giving. And also it is giving you some container ID. So this container ID or the name is provided by the Docker daemon itself when you're creating a container. Say for example, I want to give my own name actually. So how to give it? I will try to run one more thing. Like suppose for example, Docker container, I'll just say run -d, and I'll just say whenever you want to give your own name, say for example, I'm giving the name something like a -fn, name is an option you have to give it. And then say for example, I'll give the name something like a test1. Okay. And the image name is httpd, right? And say enter. See, it is trying to check whether HTTP is there or not. No, it is not there. It is trying to download it and it is trying to run it actually. When I try to run a Docker container ls, now can you see that? No space left here. See here, no space left here. Oh my God. Because we used, right? Let me do this. Let me go back to my Linux machine. Right here only I'll run it actually. Right? What is it actually? Docker container run -d -fn name test1 and httpd.
Sir, one question.
Hmm.
Here you are using detached mode. Sometimes last time you are used interactive mode and detached. Both arguments you are using, right?
Right, you are detaching mode. Yeah,
Yeah,
I
you
will
are
do
using
this.
interactive and detached. Both are using.
Yes, yes, sir. I
Finally,
will
it
dis.
comes result is only detached mode only is showing, correct?
Correct. I will discuss that. Don't worry. So that's what in today's session, guys. Whatever I'm command executing, don't think much about it. Just leave as it is. Just think that Rajesh is executing some command. He's trying to explain me some concept. That's all. Tomorrow and all, from next time, what happened when we will deep dive into all these commands because we will try to dig every option and try to make you understand. Right. So that you'll understand all your doubts will get cleared when I'll try to explain about all the command options actually. Right. Okay. Now you could see that actually it is running. Now if I do a Docker container ls, so you're actually giving a name here. Can you see? You're giving a name. So this is a name you're giving it actually. So you said that Rajesh, I want to run one more container. Right. No problem, sir. You can run one more container, but you have to just give a different name. So here it will be something like a test2. So you're running one more container. When you do a Docker container ls, can you see that you are running two containers? The same container running HTTP image only, but you're running, and here you could see that test1 and test2 you are giving it actually. Right. Now the thing is that what I wanted to say here that when you're running a container here, the container is occupying some memory. We don't know, some memory is provided by your Docker daemon itself. So but when I'm running the container, I'm not restricting anything. I'm not saying that, okay, it has to be given this much of memory only, this much of CPU need to be given, or this much of RAM disk memory is to be given. I'm not specifying anything when I'm running a container. Automatically, the Docker daemon or Docker server, whatever it is running, right, it automatically allocates some memory, some CPU for this newly created container. Suppose you want to restrict it, I'm saying, suppose you want to restrict it, then what you do basically that you can restrict it with help of a Docker container run -d. I'll just say -fn name. This time I'll give the name as a test3, right? There is something as a -fn memory. Okay, you are saying that Rajesh, I am restricting the memory to something like 128 MB and the image name is HTTPD and say enter. See guys, it is running it, right? When you try to do a Docker container ls, you could see that the test3 is running. But this test3 image, it is actually running under the restriction of 120 MB. It will not use more than 120 MB. This container cannot use because you are restricted in the command itself this 120 MB, right? How to verify it actually? So you can just say Docker stats. If you execute a command Docker stats and say enter, right, you could see that the test3 it is running only under the limit of 120 MB only, whereas other one test1 test2, can you see it is running under the limit of 950. The maximum is 957 MB or maximum 1 GB of memory is given, out of which it is only using 6.4 MB only. But here what happened, right, you can restrict it actually. You can restrict it actually. Okay, so it means that you can even set the resource limits while when you are creating a Docker container. And that is very important. We should have every information about how we can restrict the resource limits for whenever you are creating a Docker container. Am I clear on this, sir? Is it fine? So we will see all these things. What is this memory limits and everything in our upcoming sessions.
For storage as well, so how we can define
Everything.
that?
See, that's what I will do. I'll just say limit. See, Docker container run -help. See, you'll get all options, sir. If you go up, see, -fn memory, -fn label, you will get all the information about the limit sets from this option. So -fn device list, what's the device you have to identify. Same thing for the C groups. You can give many options are there. You can try to find out and we can give the limits actually. Users, volume, what is the volume you need to provide for it. All those things we can provide it actually. So whatever we created so far in this, like, right? So in Linux, we have a concept called as namespaces, which allows to create all above requirement, actually, right? All above requirement. Like it creates Like what are the creates? It creates, no, not all about record, sorry. It allows to create. What it will create, we know that Rajesh, it's going to create a process tree, right? Process tree for isolated areas. Isolated area, but your container, we call containers an isolated area, right? Right, area, which is called as, what is it? PID namespace, right? And also like you'll try to get many other information. Now the thing is that here, when you're trying to run a Docker container and this command, whatever these commands are there, right? Hyphen f in memory, here restricting it actually so that it should run within 120 MB, the maximum memory size which are allocated in 100. How you are able to do that? Because that in Linux we have something as a C groups actually. The C groups, it is used for restricting the resource limits for every container creation like this. So namespace is something where whenever you want an application run inside a container, what are all the components it needs to run it? All those things are provided by the namespace. After that, if you want to put any kind of a restriction onto the container which is created, right, in terms of resources, right, then the restrictions can be provided with the help of a C groups actually. Clear, sir? Okay. So now, okay, I will continue from here. I think we'll stop it. It's been more than 2 hours now. Okay, and what we can do, what is our next class, that we will continue from here. Next session, that is tomorrow, we'll see. Tomorrow's we'll have 2 sessions, guys. Okay, next session is something like where we will continue. We'll continue from here itself actually. Means I need to still discuss about this itself actually, the namespace and C group, which will be discussing some more things about the namespace and the C groups and everything. What are the restrictions and how exactly with the help of this namespace and C groups, actually Docker is creating a container. We'll be discussing about in detail about that. Like, and how this process trees, PID names and alls are formed. Those things, and a little bit intern. I'll be talking some 20 minutes. I'll talk about that, and we will try to deep dive into the Docker Docker daemon. It will be the Docker server. What intern Docker has, right? That thing we'll be discussing it, and we'll also be discussing about the images. What images we have understood something, but we'll go more into images and try to learn about what are the distro images and distro-less images, right? This is something which we'll be discussing tomorrow session, and then we will kickstart learning about the Docker with the help of a Docker commands. So this is what we'll be covering in our next sessions. Okay, so even I want to discuss more about the Docker architecture one more time, because in the Docker architecture, I'll be discussing about many other stuffs actually. So this would be a quite interesting session to learn. Anyhow, we understood something with a high level. What is the Docker architecture? We'll go a little in detail about the Docker architecture, try to understand it. For a knowledge sake, even for in many companies, right, where, like if you're going for very big MNC companies, right, good MNC companies, definitely they'll ask you to explain about the Docker architecture. So what the Docker container contains actually, they will ask you about all these things. So you have to say that the Docker contain the Docker engine or the Docker daemon. It contains a lib container. It contains the Docker API. It contains intern, right? It has a namespaces. It has a C groups, everything, right? It has something known as a like a run C. It in turn calls a run C, and there is something like a shim. Shim I will created for every container. There will be shim created. So all such things you have to tell the flow about when you're creating a Docker container, how Docker container in turn will going to create a container, that and all, how Docker daemon is going to create a container, that also we have to discuss. That's all part of your Docker architecture actually. Am I clear, sir?
Yes,
Okay.
sir.
See, I'm telling you about Docker command. Now, when it comes to I'm telling you now only upfront, you will come across something like a Docker file later. What is Docker file? You will not believe, sir, this Docker file itself, I will be explaining around for 10 hours, sir, with various examples. Countless examples. You will feel bored only with this class. It will be that almost like 4 to 5 sessions I'll be only taking on Docker file. Every session will be 2 hours. So our course will go more than 30 hours. It will go beyond 40 hours. It will go, because I am planning to take a Docker file to much extent, and Docker security. When it comes to Docker security, I'll be covering 2 to 3 tools. One is nothing but the Trivy tool. One is about the Dockly, and one more is the Docker Scout. I'll be discussing about these tools when it comes to Docker security. Again, this will take time. This will take me around like 3 hours or 2 or 3 hours. 2 hours, I'll complete this all. But this is all nth moment, last moment. I'm not covering now. So let us cover all these things first. Docker file is a very, very interesting. Docker Compose is good. Docker Swarm, Docker networking, Docker volume. All these are fantastic features and fantastic thing which you have to learn. And I'll be adding on some of the advanced things which I've learned recently, all those things in our class. Right? Okay, guys. Thank you then. We'll meet tomorrow. So, guys, I mean, everyone, sir, are you able to understand everything today's class? Where is Vinod? Are you able to understand today's session?
Yes, sir. Very good. Nice. Thanks.
Okay, sir. Thank you.
Yeah.
Dan,
Rajesh, please. The Docker security. So like so is it security to protect the Docker file? Like
sir, it has to say when you create a Docker image, right? Docker image itself has some vulnerabilities, right? There are some security loops within the image itself. To find out that, you will have these different tools actually. This tools does different. So we'll be learning about what is this Trivy tool all about, Dockly or Docker Scout all about, how it does the image scans and how it gives you the vulnerability checklist. Right, all those things. It is good that you have to showcase and resume also that you have implemented all the security checks during when you're writing a CI/CD pipeline. Right. This comes under your Docker security or Docker like DevSecOps, right? One of the thing in the DevSecOps is that add on all the security checks when you are building a Docker image. While building after post building a Docker image, you have to run a Trivy scan, or you have to Trivy files image scan you have to run, or is a Docker image scan you have to do, or is Docker Scout image scan you have to do. So that it is going to give you all the vulnerability checks in the image, and then like you will be able to fix it also. It will give you, okay, you're using this base image, but this image has so many vulnerabilities actually. Please use this image. You instead of this, please use this image like that. It will give you the information. Then you have to go and you have to use that appropriate image. Of course, assume that your Docker image, you're building it, you might be using some dependencies, but the dependency itself is having a vulnerability issue actually. So there also the Docker Scout will give that, okay, you're using that dependency, but the dependency has a vulnerability issue. Please use that other dependency which is greater than this version. Like that, it will give you the hint or the information it will give you. So always, whenever we are working in the real time, we'll try to run the image, whatever we have built, right, under this security scan checks actually, Docker image scan checks.
Yeah, Rajesh.
Rajesh, whenever we run the Docker command to pull that image, does it by default checks latest image, like the latest tag, or like, because once you run the command, it actually pulled the tag with the latest, and some did not. So by default, it pulls the latest, or like how
It pulls the
it is?
latest, sir. Yes, it pulls the latest. That's a very good question, sir. We will be understanding about that also when it comes to the tagging, right? So
Okay.
what is a image tagging is all about, and how exactly when a Docker client is when the Docker daemon is trying to pull the image, like how is going to pull it, what kind of a tagging it checks it. That's very interesting things which we'll be discussing also in detail. We have to discuss about that. But right now, just go with the blind assumption that it is going to download the latest only.
Okay, Rajesh.
Right.
Cool.
But in the real time, you might not have a latest. You might have some version number like something my image colon 1.0, my image colon 2.0, my image colon 3.0. So in that case, which is the latest it will try to pull? It will try to, based on timestamp, it checks which is the latest which is available in the either the private registry or in the public registry. Like whichever the latest with the timestamp is there, only that one it will pull it actually. But by default, how the Docker daemon is designed, that whichever is image which is having with the colon latest as a keyword, that only it will get download if you are not giving any version while doing a Docker container run or Docker pull image. If you're not giving any convention or any label or any tag value, it will by default it will pull the latest only if the tag is available. If the tag is not available, it's going to check which is the latest. Based on the timestamp, it checks which is the latest which has been uploaded recently, or that one it will try to pull it actually.
Perfect. Thanks.
Yeah. Okay, guys. Thank you. Then we'll meet tomorrow, and tomorrow also same timing 8 o'clock. So tomorrow's timing is something like 8 to 9:15. I will take 1 hour 15 minutes. We'll give a break of half an hour, and then again we'll continue from the 9:45 to 11. We'll continue like that. Tomorrow we'll have 2 sessions. Okay.
Thank you.
Thank you. And guys, tomorrow morning we have a Kubernetes, right? We'll start with the Kubernetes. We'll see. I'll start with Kubernetes tomorrow. Or max, I'll start from Monday.
Sir,
Okay,
is
Then
is
there,
it, is it starting for tomorrow? But I thought I thought it is starting now. So I.
No. I thought I'll see, sir. Actually, every day we have to start. I thought it was supposed to be started today morning, Saturday, because today I had an interview. I couldn't do it actually. I will see tomorrow morning. I'll start at 8 o'clock. If I'm not starting it actually, Monday for sure I will start. From Monday onwards, we'll start, sir. And Monday if I start means, I'll try to make it continuous. Every day I will have a, because Kubernetes,
So
some people are eagerly waiting. All are waiting. Even myself,
yeah,
I am
yeah.
also eagerly want to start this.
So what will be the timings, Rajesh? Like on
Sir,
for
I
the.
will tell you, Docker is something as of now we have kept the weekend itself,
Okay.
Saturday, Sunday, which we will try to shift it later. Now let me start the Kubernetes now, either tomorrow or Monday morning, anytime. I'll start. Once I start it, then we'll have a regular classes.
So recording is
Once I
running.
complete the Ansible, oh, I'm sorry, man. The recording is running. Oh, sorry. Thank you, man. Sorry, let me stop the recording.